Good morning, everyone. Is my voice audible now? Tell me. Shrishti, Manoj, Vishnu, Anshri, Abhishek, Mashri. Yes? Okay, very good. Okay, Mashri. Now, when we talk about this chapter, right, if you recall the concepts that we have studied in class 11, then this chapter is comparatively easier one. Yes or no? Tell me. Yes. Okay. So we will, okay, guys, right? So I was just messaging to everyone in the group. Okay. So we will start with properties of solid. When you talk about solid, right? Okay. When we talk about solid, I hope all of you remember the basic property of solids. I need not to tell you what is the definition of solid, right? Yes. Right, everyone? Now, when we talk about the properties of solid, okay, so we are basically concerned with one peculiar property, which is your elasticity, right? Elasticity. So we are concerned about the property called elasticity in solids. Now, when we talk about elasticity, okay, so what is the meaning of elasticity? Tell me, what is the meaning of elasticity? What do we mean by elasticity? Tell me. I can say that, okay, elasticity is a property of any substance to regain its shape. Yes or no? Yes or no? Tell me. Right? If any external force is applied, then yes, Prashant, right? Then the object will try to regain its shape. Yes, very good. Okay, now if I'm saying, okay, the property is regaining its shape, so there must be some opposite force, or I might say there must be some restoring force. Yes or no? Tell me. Yes or no? Right? For example, the best example is spring. Okay, whenever we talk about spring, suppose we talk about spring, I can say that in spring, I'm having a restoring force, which is called as spring force, right? Okay, yes. Yes. So here we will be talking about, okay, we'll be talking about this property, which is elasticity and the strength of materials. Okay. Whenever we talk about strength of material, we talk about how strong it is. How can we say a material is strong or weak? Tell me. Think about it. Suppose if a wire can hold 5 kg and second wire can hold only 2 kgs, right? So which of them will be strong? Yes, very good, right? It is. Yes, so we can say that strength can be defined on the parameters, which is tensile strength, elasticity, uh, your breaking point, and all those things. Yes or no? Tell me, yes or no? And when you talk about the properties or the yes, when we talk about the properties, right, specific properties, I can say that those specific properties are stress and strain, right? So if an object can withstand more stress, then it is stronger. Yes or no, right? Yes. Yes, for example, when you talk about any pillar, right, or any rod, okay, I can say that if an object can withstand more stress, then it is strong. If it can withstand less stress, right, or it breaks, then it is weak. Okay, so the term that we are going to discuss throughout this chapter is stress and strain. Now, I hope all of you know what is the meaning of rigid body. Tell me, right? I hope all of you know what is the meaning of rigid body. Yes, rigid body means there is no elasticity between, tell me, between the molecules, right? There is no elasticity in this object. Okay, right? Yes, zero elasticity. So obviously there's nothing like perfectly rigid body. Okay, 100% rigid body is not possible because even though when you talk about the macro level, even though on macro level the molecules might not move, but when you talk about micro level, right, if you supply any force by any mean, okay, I can say that the body will, tell me, change its shape. Okay, right? Okay, so yes, yes. Okay, so when you talk about deformable body, I can say that deformable body is basically your substance which can change its shape. Okay, right? Got it? Now, if it can regain its shape, then it is called your elastic body, and the property is called as elasticity. Okay, the properties is called as elasticity. Now, we know that when we talk about elasticity, okay, so we are talking about restoring force. We are talking about restoring force. Okay, so when we talk about elasticity, I can say that, okay, it is the property of a body by virtue of which it tends to regain its original shape and size. Okay, got it? Now, I can say that technically all solids show this property. Okay, but to which extent depend on, tell me, its restoring force. Okay, so think about it. Think about it. When you talk about this, okay, we will discuss about two parameters. First is stress. Now, what is stress? Tell me, what is stress? Think about it. What is stress? So I can say that stress is basically, yes, restoring force per unit area. Okay, stress is restoring force per unit area. Okay, got it? Right? So when you talk about stress, it is restoring force per unit area, which is F by A, as well as that. So dimensionally, it is same as pressure. Dimensionally, it is same as pressure. Okay, but definition wise, the only difference is it is restoring force. Okay, right? Now, technically, restoring force is equal to external force because just think about it. Now, if you pull your spring, okay, if you pull your spring with a force of 10 Newton, so obviously the restoring force would be 10 Newton only. Yes or no, right? If it is balanced, then restoring force is equal to your external force. Okay, now think about it. Think about it, right? Before thinking about any other parameter, think about it. Suppose you're applying, suppose this is your spring. Okay, this is your spring. And you're applying a force in this direction. You're applying a force in this direction. So the restoring force will be in this direction. Okay, which will be equal. So I can say that stress is equal to F by A, right? A. So forget about what area I'm talking about because there is multiple kind of stress over here. I'm just trying to let you know the basic idea. Okay, we'll discuss about all the type of stress. Now, if you apply more force, tell me, if you apply more force, right, it will be, tell me, it will be, I'm talking about, Prashant, I'm talking about equilibrium position. Okay, I'm talking about equilibrium position. Now think about it. Now, when you stretch it, and right, keep having that force, right? It will be in stretched position only. Now, tell me, yes or no? It will be in stretched position only, right? Now you got it. So at that point, your F external should be equal to F restoring, and restoring force is depending on the external force. If, think about it, if your spring is in natural position, if it's in natural position, will there be any restoring force? Tell me, will there be any restoring force? No, nah. So it makes sense, right? Now we know that, okay, I can say that this force, right, if the restraining force is more, or if this external force is more, there'll be more elongation. There will be more elongation, or there'll be more change in length. So I can say that, okay, stress is directly proportional to change in length. Yes or no? Tell me, yes or no? Yes. But is it 100% correct statement to say? Is it 100% correct statement to say? No, right? Why? Why so? Because when you talk about, think about it. Suppose I'm having one rod of 1 meter, okay, and the second rod of 2 meter, and this rod is extending, right? Suppose 20 centimeter, but this is extending 30 centimeter. Okay, and I want to say, okay, out of these two, in which rod we will have, tell me, we will have more stress, first one or second one? Prashant, at equilibrium. Okay, right? Yes, obviously, because when you talk about unbalanced forces or balanced forces, think about it. Now, here I'm talking about equilibrium, at equilibrium. Okay, so at equilibrium, restraining force is always equal to external force. And we always talk about equilibrium, okay? Now, first one or second one, tell me, stress will be more, same material, Harsha, same material, okay? So obviously, logically it might, right? Logically, you might say it is first material, yes or no? Because when you talk about 1 meter, in 1 meter is extended to 20 centimeter, but this one in 2 meters, it is extended to 30 centimeter. So if you talk about per unit meter, it is extended to how many? Sorry, what distance? It is 15 centimeter. Yes or no? 15 centimeter. So don't you think that the best way is to calculate per unit length? Yes or no? Yes or no? So I can say that, okay, I'll just write a better relation, which is stress is directly proportional to change in length, right? Okay, and this term is called as strain. Okay, right? Got it? So this is called as strain. So there's a very simple relationship, which is stress is directly proportional to strain. And that is given by a scientist named as Hooke's. So this is known as Hooke's law. Okay, this is known as Hooke's law. Now, when you talk about this, obviously we have to remove this proportionality constant, right, everyone? Now, when we remove this proportionality constant, I can say that stress is equal to K into strain, right? And this K is basically your coefficient of elasticity. This K is coefficient of elasticity. Now, depending on different type of strain and stress, this K, the name of K will change. Okay, the name of K will change, right? Okay, it will be modulus of elasticity, young modulus of elasticity, bulk modulus of elasticity, modulus of rigidity, right? It can be different thing depending on the type of stress and strain. We will see that in later. Okay, but I'll just write a general expression, which is K, okay, where K is coefficient of elasticity. And don't you think that the K should depend on what? Tell me. K should depend on material, right? K should depend on material. Okay, got it? Tell me. Yes? Okay, very good. Okay, very good. Now, when you talk about, think about it. When you talk about stress, I already explained what is stress. Okay, stress is external deforming force per unit area, right? Dimension formula, you know, unit, you know, it is just same as pressure. Okay, type of stress. Now, when you talk about stress, it depends on deformation. Yes or no? Tell me. It depends on deformation. Makes sense? Now, when you talk about any body, okay, any body, what kind of deformation can occur in that body? Just think about it. Let's try to think. Okay, so I can say that, okay, suppose I'm having a rod-like thing. Suppose I'm having a rod-like structure. Okay, right? Yes. So there will be change in this length. There is change in length. Okay. Then there will be change in area or volume. Okay, right? Change in length, area, or volume. Now, when we talk about change in area, okay, or change in length or change in volume, depending on that, there might be different kind of stress or strain. But this is about the change. But when we talk about force, right, direction of force, I can see that, okay, direction of force can only be in two directions. Either it can be perpendicular to the surface, yes or no, perpendicular to the surface or tangential to the surface. Makes sense? Either perpendicular or tangential. Okay, right? So we have two different categories. First, depending on the change in length, volume, right? Mostly it's change in length and volume because area again comes under length only. Okay. Second is change in, tell me, due to direction. Prashant, if it's at an angle theta, okay, if it is at an angle theta, then it will be divided into two components, right? Okay, then we will have multiple stress. Okay, we'll see problems based on that. Okay, right? When you talk about spring, okay, when you talk about spring, so a spring is the best example of that, right? Because when you pull up spring, when you see the steel rod, right? It is actually, when you talk about steel rod, it is actually at an angle, okay, at an angle. So the force will be both perpendicular and parallel when you take the components, okay, right? Okay, but whenever you talk about any force, it will be either be your perpendicular component or tangential component. Now think about it. First, we'll talk about perpendicular component, right, which is your normal stress. Okay, it is also called as longitudinal stress. It is also called as longitudinal stress. Longitudinal. Okay. Now, tangential stress is also called as shear stress. Shear stress. Okay. Got it? Right? Now, we know that if I'm having normal stress, okay, if I'm having normal stress, so I can say that normal stress is responsible for the change in length. Okay. Normal stress will be responsible in change in length. Right? Right? Yes. Longitudinal stress is lengthwise. That's what I'm saying now, right? Normal stress is basically longitudinal now because, right, it will leads to change in length. See, normal stress means force is normal to the surface, okay? Force is normal to the surface. Got it, Prashant? Right? Do not get confused with the name, okay? Longitudinal stress and normal stress are same. It's just the name given. Longitudinal toward the length, right? Along the length, and normal is in terms of force, which is perpendicular to the surface. Got it? Right? So this is basically your any notation can be used. Okay, so this is suppose stress, which is sigma is equal to P by A. Now, when you talk about this longitudinal stress, think about it. I'll just take one example, right? Think about your pillars, okay, right? This is case one, pillars, and second case is your rod, okay, right? We have two cases. So this is case one, it is your pillar, and second case is a rod. Now, what is the difference between these two cases? When you talk about pillar, right, pillar on the ground, right, it is supporting the weight is at the top. Yes or no? Tell me yes or no. So the force will be in downward direction. So restraining force will be in upward direction. Make sense? Right? and due to this there will be, tell me, there will be decrease in length. Yes or no? There will be decrease in length, right? Because due to this weight there will be compressive force. Okay, right? But when you talk about this, suppose mass is hinged here, right? This is weight. Okay, so this will again pull this rod. Okay, pull this rod. So I can say that this rod will elongate. Got it? And this will compress. Makes sense? Makes sense. Both the changes will be along the length only, but in one case the force is compressive, and the second case force is, tell me, expansive, right? Yes. So I can say that depending on this, depending on the type of force, we have tensile stress and compressive stress. Tensile stress is when the length will increase, and compressive stress is when length will decrease. As simple as that. Okay, as simple as that, right? So basically it is just the term, otherwise the definition will be same. Yes or no? Yes or no? Tell me. Right? Yes? Okay. So we can say that sigma is equal to K into delta L by L for both the cases. Delta L by L for both the cases. Now in this case, K, right, is called as Y. Y delta L by L. Got it? This Y is called as Young modulus of elasticity. Right? This Y is called as Young modulus of elasticity. Or I can write like this: F by A is equal to Y. Now delta L I'll write as X by L. Got it? Tell me, got it? So this is the expression which we'll be using a lot. And this is the only expression that you need to think about. Okay, the only expression that you need to think about, because you can derive any other expression with this, using this. Make sense, right? Okay. Okay. Now, tensile stress, I already gave you example. What's the meaning of tensile stress? Okay. Then if a tensile stress is more, suppose if tensile stress is more, I can say that, okay, Young's modulus will be more, right? If tensile stress is more, right? Can I say that the molecule, sorry, the object will have more, tell me, more ductile nature? Yes or no? Yes or no? Because if you apply force, it can stretch a lot, right? It can stretch a lot. The change in length will be more. So it will be better, right? It will have better ductile nature. Make sense? Got it? Yes? Yes. Okay, very good. So compressive stress we have discussed. Okay, compressive stress we have discussed already. Now, when we talk about tangential stress, think about it. As I told you, the tangential stress is the stress which is applied, okay, when, tell me, when the force is tangential to the surface. Now, if you see this, okay, I hope all of you have seen the toy in which you punch it and it goes back and then it regains its shape. Yes or no? How many of you seen that type of toy when you were a child, right? Anyone? Yes? So the phenomena, okay, the physical reason for that toy will be something else. Okay, it is not the same as this, but I'm just giving the analogy how this force will act. Okay, now suppose you are applying a tangential force. You are applying a tangential force. Now we know that, okay, we know that the height is not changing, length is not changing, but when you talk about this initial point, so every point is actually changing its position. Yes or no? Tell me, yes or no? Every point is changing its position, right? Got it? The only difference is now they're not changing the position toward the length. They're changing the position perpendicular to that. Okay, they're changing the position perpendicular to that. So intuitively, can I say that? Okay, intuitively, I can say this force per unit area, which is the stress, should be directly proportional to delta x by L. Yes or no? Because I cannot say now that if I'm talking this delta x, then this length, because I'm talking about this point, which has changed. But if I'm talking about this point, right, so delta x is this one, right, and L will be this one. Even though the ratio is constant, na, right, because the angle theta is constant, right? So that's why I'll take delta x by L. Now we know that delta x by L is nothing but tan theta. Delta x by L is nothing but tan theta, right? And normally when you talk about, okay, right, normally this angle is very small. Normally this angle is very small. So we often, right, just write it as theta. Okay, we just write it as theta. Okay, so at many places you can say that theta will be the strain. Now, since it is perpendicular, sorry, since it is parallel, right, parallel to the surface. See, I'm saying surface, okay, right? This is called as tangential stress or shear stress. Shear stress. Okay, got it? Tell me. So I can say that, okay, F by A is equal to, now this is shear, so I'll have another constant which is eta. Okay, this is called as modulus of rigidity. Okay, because if this, think about it, if this delta x will be less, I can say that the substance will be rigid. Yes or no? Yes or no? If this theta is very big, right? If theta is more, if by applying a small force, the molecule will move a lot, then obviously the rigidity will be less, then it will be fluid, right? That's what we talk about in next topic, right? Which is fluids. Yes or no? Yes. Now here, either I can write delta x by L, delta x by L. Now remember, delta x is x-axis, L is the length in y-axis, or I can just write it as n d into theta. Got it? Tell me, got it? Right, everyone? So this F by A is called as shear stress. This is called as shear stress, and this theta is called as shear strain. Okay, this is called as shear strain. Right? Got it? I hope all of you understood this concept. Okay, so yes, so this brittle behavior will be because of that. If the shear stress, okay, is less, then it is brittle. Now strain, we have studied what is strain, which is change in dimension by original dimension. Now again, dimension written because it can be length or volume. Okay, it is dimensionless because it's a ratio. So we talked about three kinds of strain: longitudinal, volumetric, and shearing. Okay, right? Longitudinal and shearing we discussed already. Now what is the meaning of volumetric? Now think about it. Think about it. Suppose you have a bubble. Suppose you have a bubble. Okay, bubble, right? Now suppose this bubble or any object, forget about bubble, any object is in the pond, okay, and suppose this size will decrease, obviously the pressure will be more now, the pressure will be more from all the sides. Because of that I can say that the volume will change, the volume will decrease. Yes or no? Tell me, yes or no? Right? Yes, very good. That is called your bulk modulus. So I can say that in that case also, okay, same force per unit area, which is pressure, is directly proportional to change in volume. So, but again, volume will decrease. So we will have minus delta V by V, right? Or P is equal to B minus delta V by V, right? And technically, this is not P, this is delta P. Yes or no? This is change in pressure. Makes sense? Tell me, makes sense? Right? And we know that delta V by V can also be written as, tell me, in terms of density also. Yes or no? Delta rho by rho minus, yes or no? Yes or no? Because this is the relationship which will be used a lot in numericals. Instead of giving the volume, they will change the density. Okay, right? So you can just use the relationship, okay, instead of finding the mass, finding the volume, and then changing this. Prashant, volume will decrease, na? Tell me, volume will decrease, right? So delta V is negative. Delta V is negative, na? Right? And we have to have it. See again, right? When there will be expansion, then delta will be negative. Delta V will be, tell me. So delta V will be according to that. You will put negative sign or positive sign depending on what is happening. So that is your intuitive thing. Okay. I just want to make this term as positive. Okay. Right? If volume will decrease, if delta V is negative, I'll put negative. Okay. Okay. So longitudinal strain, I hope all have understood what is longitudinal strain. What is volumetric strain? Right? All have understood what is volumetric strain? Yes. Shearing strain? Yes. This we studied. What is shearing strain? That is theta. How? Because when you talk about very less angle, tan theta is written as theta. Okay. Elasticity, we studied what is the definition of elasticity. Now, Hooke's law. So I hope all of you understood the basic idea about Hooke's law, right? Which is stress is distribution to strain. But my question is it always applicable? Tell me, is it always applicable? Just think about a rubber, right? When you stretch your rubber, how many of you observe this? Then it's not that you can keep on stretching, yes or no? Is it possible to keep on stretching a rubber or anything? No, right? Only till some elongation, yes or no? Right? After that, either it will lose its property, right, or it will break. Yes or no? That is one thing that we have observed. Yes. So I can say that, okay, Hooke's law will be straight line. Hooke's law will be straight line up to certain extent. After that, it will be, tell me, either constant or it will increase and then become constant or break after that point. Yes or no? Tell me, yes or no? Okay. So I can, yes, fracture point. Very good, Himashri. Okay. So I can say that we will define two important points. One is elastic limit. So elastic limit is what? Elastic limit is that maximum stress, okay, till which it will again restore its shape and size. Yes or no? That is the elastic limit. Or mathematically, I can say it is a point at which, till which Hooke's law will be obeyed. Got it? Yes or no? Yes or no? Right? And the next is, so this is the curve. This is the curve. So it will be straight line. It will be straight line if it always follow Hooke's law. But this doesn't happen, right? Okay, this will be your elastic limit. After this, it will either go something like this, yes or no, right? In reality, okay. And the curve will look like this. The curve will look like this. Okay, so I can say that this is your proportional limit, this is your elastic limit, and beyond which it will not regain its shape, and this is your fracture point, means it will break. Now think about it, think about it. Suppose this length is very long, this length is very long. So what can I say? What can I say? If this length is, or I'll just take one example. Suppose there's one, this is substance A, and then we have substance B. The substance B kind of thing, the substance B. Out of these two, which can be stretched more, A or B? Out of these two, which can be stretched more, A or B? Or which is more ductile? Yes, very good. A is more ductile, right, as compared to B. Okay, got it? Tell me. So A is ductile and B is brittle. A is ductile and B is brittle. Okay, right? Got it? So by this is some random, because when we talk about, yes, when we talk about different objects will have different curve of stress and strain. Okay, but we will talk about this basic one only. We'll talk about this one only. Okay, right? Now, modulus of elasticity we have studied. Okay, right? It is given by the scientist Thomas Young. So this is your Young modulus of elasticity, which is represented by Y. Bulk modulus is represented by B or K. Okay, either B or K. Now, I would request you to use B. Why? Because K is also used as compressibility. K is also used as compressibility. Okay, got it? And B is equal to 1 by K. Got it? Right? So in many problems, yes, in many problems, K will be used as compressibility and bulk modulus is 1 by K. Okay, so it's advised to use B for bulk modulus. Okay, got it? And this modulus of rigidity, which is eta. So this is the expression that we'll be using a lot in fluids. Got it, everyone? Tell me, got it? So this is the general formula. Okay, so this is the basic idea of this chapter. Now, when we talk about the type of questions, right? Let's see. First type of question is formula putting getting. Yes or no? Tell me. First type of formula is probably formula putting getting. Agree? Yes. So this is formula putting getting. Now, second example. Think about it. Try to solve this one. Try to solve this one. Everyone, try to solve this one. Okay, in this problem, what is given? Four identical hollow cylindrical column of steel support a big structure of mass. This is force given. The inner and outer radii are this. Now the area will be what? The area will be pi r1 square minus r2 square. Yes or no? That will be the area. Okay, right? Got it? That will be area. Now, assuming the load distribution to be uniform, calculate the comprehension, okay, it's compression strain of each column. The Young modulus is given. Now, you have to find delta L by L, right? Now, I guess it is quite easy. This is stress sigma by Y, which is F by A into Y. As simple as that, F is given, right? But when you talk about this, okay, we have four identical columns, right? So it will be distributed, yes or no? Tell me, it will be distributed. Got it? Think about it, yes or no? Vishnu, you didn't get the concept. That's why you're asking for length of the column, because it is not required. You ask to find stress. Okay? Got it? Prashant? Checked your error? Okay? Next one, try solving this. Try solving this, guys. Now, check your decimal place. Okay, check your decimal place. Right? Just check your decimal place. Okay, so in this, what is given? The change in length, right? Increase in length is given, right? Weight is given, Young modulus is given. Percentage increase in length you are asked to find. Okay, so it is 0.21%. Okay, 0.1%. Got it? Harsha and Vishnu, both check your decimal place. Prashant is correct, right? It is 0.21%. Got it? Okay, very good. So these are some problems that you should try. Okay, right? Please try these problems. I will send this. Okay. Next is bulk modulus. So I hope all of you understood what is bulk modulus. Okay, right? So we will use beta instead of this. So just solve some kind of problems. Okay, we'll just try to solve because we have already discussed what is bulk modulus. Okay, got it? Yes or no? Tell me, yes or no? And here it is mistake, it should be beta. It is not Y, it is beta. Okay, right? So let's see first one. This one is basic formula putting getting. This one is basic formula putting getting. Just go through this. Yes or no? Right? Delta V by V is already given. Delta V by V is already given. 0.01%. Okay. Now, if it is already given, so you just have to find beta, right? Yes. Okay. Next, shear modulus. We have already discussed this. This we have already discussed. Try to solve this one. Try to solve this one, everyone. We will try to solve more problems. Okay. Right. This is just the basic. This is just the basic. Need students? This much is enough for you. Okay. Right. You won't be asked any other problems based on this chapter. But still we'll try to solve some more problems which involve integration also, because you can just remember that as a formula. It can be used. Okay. Because think about it. When you talk about the type of questions, concept is this only. What can change? Tell me. Everyone think about it. What can change? There's only one thing which can change, right? Which is force. Yes or no? Tell me. Yes or no? Yes? Agree? Now, how can you change the force? Tell me. How can you change the force? By using a variable force. Now, variable force may be of different kind. It may be your variable mass, okay, or it may be your centrifugal force due to rotation, right? Got it? Yes or no? But apart from that, every other concept will be same. Okay. Try to solve question 5, everyone. Okay, Vishnu, correct. Like, correct means, okay, I got your answer. Manoj, okay. So both the answers are different, Manoj and Vishnu. Harsha, okay. First is to find what? First is find shearing strain. Okay, shearing strain. So shearing strain is theta, right? Which is delta x by L, right? So see guys, see. Okay, the first one is quite easy. First one is this, theta. First one is theta. Got it? Yes or no? Yes or no? Right? Which is 0.0123. Check your calculations. Okay. Second is length. So we know that theta is equal to delta x by L. So you can find L because delta x is given. Okay. Right? Okay. Now next is strain energy. Now think about it. Think about it. When you elongate something or contract something, obviously that elongation, okay, when you talk about the points on the object, okay, when you talk about individual points, so they are having displacement, yes or no? Right? They're having displacement under the action of force. So there must be some kind of work done, right? Yes or no? There must be some kind of work done. But we know that according to conservation, okay, that work done, right, should be because of some kind of potential energy. Yes or no? Yes or no? Or stored energy. So that kind of energy is called as strain energy, right? So I can say that what is strain energy? I hope all of you understood what is strain energy. Yes or no? Tell me. Yes or no? All of you understood what is strain energy? Yes. So what is the expression of strain energy? What would be the expression of strain energy? Same. Whatever we did with all the different type of work done. So this work done is what? F into delta x. Yes or no? Tell me. Yes or no? And according to Hooke's law, F is equal to K into X. K into X. Makes sense? Tell me, makes sense? Because length will be constant. No, length will be constant, right? So I'll just assume that to be a constant. Okay. So if you talk about work done, which is again kx into dx. So kx into dx integration 0 to x. So this will be half into fx. Half into fx. Yes or no? Half into fx. Yes or no? Or half kx square. Yes or no? Right? Now, if you try to reconsider this, I can say that well, I can write it like this: half into force by area, okay, very good, into x by length, okay, into area into length. Yes or no? Yes or no? Right? Now we know that F by A is nothing but stress. Half into stress into X by L is nothing but strain. And A into L is nothing but volume, initial volume, V initial. So this is the formula. Now when you talk about strain energy per unit volume or work done per unit volume, so that is half into stress into strain. Or if you want to further simplify it, right? Work done per unit volume is half into stress is what? Y into strain. So it is y into strain square. Strain square. Make sense? Tell me, make sense? Easy? So all the questions that will be asked based on this will be get. Okay, got it? This is something that we have already studied, right? So this is strain energy density, which is strain energy per unit volume, which is half into stress into strain. Try to solve this one basic problem. Try to solve this basic problem. Okay, yeah. Yeah. Now let's try to think about this kind of situation. Okay. Chemistry, okay, the answer was this 2.4 into 10 power minus 5. The answer was 2.5 into 2.4 into 10 power minus 5. Okay. Okay, the next topic, I hope all of you understood. Tell me guys, all of you understood this? Yes or no? Okay, very good. Right? Very good. So please check your answers. Okay, everyone check your answers. Okay. Now, this is just the basic. Okay, this is just the basic. Now think about it. What kind of question can be asked? Tell me, what kind of question can be asked? In this, right? Let's try to think what kind of question can be asked. Okay, so this is just the basic theory. When we talk about the different type of problems that can be asked, okay, so the very common is the combination of rods of springs. Yes or no? Tell me, the combination of rods and springs. Yes, right? Where two rod, a screen is not visible. Okay, wait. Yeah, sorry. It's fine now. Is it visible? Right? Yes. Okay. Very good. Now, when you talk about the combination, I can say that we can imagine the combination. Okay, we can imagine the combination in the same way as resistance, right? Which is either in series or in parallel. Okay, either in series or in parallel. So we have completed this elasticity. Wait, we have completed this elasticity, stress. Wait. I'll just go through this. We have completed this. Okay. Yes. Then completed this also. Volume stress, tangential stress. What is strain? What is volume strain? Shearing strain. Now, again, there's something called torsional strain. Okay. There's something called torsional strain, which is kind of similar to shear strain. Okay. Kind of similar to shear strain. It's just that one point is fixed and second point is shifted. Okay, so it is almost similar to torsional strain, sorry, shear strain. So you guys just need to remember the formula. Okay, you guys just need to remember the formula of torsional strain. So this we completed. Yield point, breaking point. Yes. So you can find a problem based on this. You can solve these kind of problems easily. Hooke's law we completed. Okay, now yeah. So this is the type of problem I was talking about, right? Just see this problem. Everyone see this problem. Now in this problem, what is given? You have three different kind of rods, having three different Young modulus. Okay, so either I can find the change in length in B, then change in length in C, then change in length in D, right? And then tell me, find net change. Yes or no? Tell me yes or no. Yes, got it. But in order to do so, right, I have to consider whenever I find change in length in C, okay, it should be change in length in B plus change in length in BC. Yes or no? Tell me yes or no. Right? So because when I talk about this point, I'm talking about this point, how much this point will go down. Okay, so we'll see how much this point will go down, then plus how much this point will go down, plus how much this point will go down. Got it? Right? Okay, very good. Very good. So we will just see what type of questions. Okay. Now this is something I was talking about. Now, whatever we studied till now, okay, in tensile stress is that mass is associated, mass is hinged at the bottom. Okay. No, Vishnu, you just find, right? You just need to find the change in length of this. Okay. Mass is considered. Now mass will be considered. Mass will be considered, obviously. Okay, see, that's what I was talking about. But again, in that case, right, the mass of the wire is negligible. Yes or no? Tell me. Think about it. Now, common sense, right? That is what we're talking about. In that case, in the previous question, mass of wire is negligible. So you need not to worry about that. Okay, right? Now, this is the case where mass of rod is given. Mass of rod is given. So as I told you, okay, if mass of rod is given, what will change? Tell me, what will change? The tension force, because obviously the restoring force will be tension force. Now, tell me, restoring force will be tension force. Tension force will not be constant, because when you talk about this point and this point and this point, the tension force will change, right? Got it? Because mass will change. Mass at this point will be this much only, but mass at this point will be this whole. Mass of this point will be this whole. So as we go up, mass will change. So I can say that, okay, tension will be mass by length into length, this length into G, right? Got it? Right? And just put in the formula. If you just put in the formula, you will get x into dx, which is this. Change in length is mgl by 2ay. Now, if you compare from the first case in which the mass is not there in the rod, it's just hinged, right? Then the formula of delta L was what? mgl, which is fl by ay. Yes or no? Tell me yes or no. Right? Now, if you compare this, right, the only thing that changed is 2 is divided in the denominator. Okay, got it? Now, the tension in this case, tension is changed because the mass is variable, right? There's another way of changing that, right? If it is rotated, think about it, that's second case. If it is rotated, then also the tension will change. Yes or no? Tell me yes or no. Think about it. Yes, see. Okay, see this. So it's better to write this formula only. If you don't want to calculate, you can just write down the formula. Okay, if it is rotated, then due to centrifugal force, here mass is negligible. I'm not considering mass, but centrifugal force will be responsible for, tell me, tension, right? Centrifugal force will be responsible for tension, right? Which will vary to point, because when you talk about centrifugal force, it is mv squared by r. Mass is also changing, r is also changing. Okay, yes, right? So in terms of omega, if omega is given, you have to change v in terms of omega. So this will be the formula, right? So just write it down. You can just write it down. Okay. So tension is given. So you can find the stress using the basic formula. Make sense? Tell me, make sense, everyone? Got it? Yes or no? Right? But again this will be integrated because this is dy by dr. Now again this will go this side and it will be integrated. Okay, so if you want to write the last integrated formula, then this will be the integrated formula. This will be the integrated formula. So this is the actual formula. You can write down this formula in your notebook. Okay, you can write down this formula in your notebook, this one. Okay, right? Got it, everyone? Write down this formula. Neat students, J students, instead of deriving it, you can just write down. So this is the change in length when a rod of length L and density rho is rotating at an angular velocity omega. Okay, got it? Right? Got it? Just write it down. Because this might be asked. Okay? Remember this, then it will be formula putting getting. Okay, right? Now, see, as I told you, okay, the only thing that will change is force. Okay, the only thing that will change is force. So they can give you different type of problem based on that. Okay, so this problem is same as the problem which we discussed. Okay, which is FL by 2AY. You have to understand what is being asked. If you understand what is being asked, then you can easily find the force using integration. Okay, got it? I hope all of you understood this kind of problems. Tell me. I hope all of you understood this kind of problems. Yes? Very good. Very good. So let's try to solve some more problems based on that. Okay, right? Some more problems based on that. Now think about this problem. I'll just show you. Think about this problem. Okay, solutions are already given. Just try to have a look. Just try to have a look. Okay, how we need to solve. Okay, these two problems. The first one, this one only. Okay, got it? Tell me, guys, got it? This is what I was talking about, right? Which means when we don't have dv by v, okay, I can write down that in terms of density. Okay, yes, I hope all of you remember. So this is the example, okay, of what I said. Right, everyone? Got this? Got this? Yes, very good. Anyone have any doubt? Tell me, anyone have any doubt in this? Anyone have any doubt? No? Okay. So the next thing that I was talking about is, okay, second last step. Okay, Abhishek. Now in second last step, right? In second last step, what we do, now think about it. The formula was what? Formula is delta P. Start with formula. Delta P is equal to minus beta delta V by V. Delta V by V, right? Now delta V by V minus delta V by V can be written as what? Tell me. Beta minus delta V by V can be written as delta rho by rho. Delta rho by rho, right? Right? Got it? And we know that delta P is nothing but change in pressure. Yes or no? Yes or no? Which is rho GH. Rho GH. Okay. Got it? Tell me, got it? And beta is given. So can you find H? H is equal to beta delta rho by rho G. Okay. Got it, everyone? Tell me, got it? Yes? Okay. So the next topic that, sorry, the next concept that I was covering was, right, this. If we have two different rods, okay, two different rods of different young modulus or two different springs, I can consider them as equivalent, one equivalent, same as the resistance one. Now think about it. What do you think? This is in series or parallel? Tell me. What do you think? This is series or parallel? This combination in A and B is series or parallel? Yes, series. Now, this is not, again, the formula is not same as resistance. Formula is same as capacitance. Remember, the formula is same as capacitance. Means when we talk about series, then 1 by K equivalent is equal to 1 by K1 plus 1 by K2. You can derive it now because force will be constant. Yes or no? Force will be same for both this one and this one, right? Okay, so if you try to derive, you can get this because force will be constant. So this will be same as the capacitance. Okay, got it? Tell me, got it? Right? So can you solve problem like this? Tell me, can you solve problem like this? Yes or no? This and this series, then this and this parallel. Okay, got it? Tell me, got it? So can you solve question number, right? This problem. Everyone try to solve this problem. Everyone try to solve this problem. Think about it. I hope all of you remember the formula of time period. Yes or no? See, these are the easy problems if you actually know what you have to do. Okay, right? Everyone, please try to solve. What is the formula? Think about it. What will the change? We know that the time period, formula of time period, I hope all of you remember it. 2 pi root of, tell me, m by k. Yes or no? Yes or no? Yes. But in this case, what is k? K will be k equivalent now. K will be k equivalent, right? Just put the value of k equivalent. As simple as that. Makes sense? Tell me, makes sense? Right? And when you talk about k, what is k? Tell me, what is k? K is a spring constant. Now, in terms of this, we know that F is equal to kx. And if you compare this with F is equal to YA by L into X. So this will be okay, YA by L, right? Got it? Right? So find K. So K1, K2 you can find Y1, A1, L1, Y2, A2, L2. Then K current you can find, just put it, you will get the answer. Easy? Yes. Yes, Manoj. Easy? Everyone got this? Tell me, everyone got this? So this is the relationship. Okay, so these kind of problems you can find. Tell me, these kind of problems you can find. Try to solve this one. Try to solve this one. This is a good problem. Everyone try to solve this one. This is a good problem. we'll try to think what can change, right? What kind of problems can be asked. Yes, yes, very good, Harsha. So see, right, when you talk about this problem, I hope all of you can see this problem clearly. Okay, right? What is asked in this problem? What is asked in this problem? Tell me, everyone. I can say that this is your hanger. This is your hanger, and this is dropped. This is dropped from height h, right? So the yes. So when you talk about this, yes, right? So we have to talk about this. Now it is dropped. It is dropped. So it will have some energy. Yes or no? Tell me. It will have some energy, right? And this energy will transfer to this. Yes. So we can use conservation of energy. Yes or no? So after striking, it will go down, suppose to this level, and this is x. This is x. Okay, right? This is x. Yes. So energy of this is what? Mgx means mgh plus x total. Okay, and the energy of this is half k equivalent x square. Got it? Tell me yes or no. Yes or no. Right? So it's easy to find. It's easy to find x max. Yes or no? It's easy to find x max. Everyone can see. I hope all of you can zoom the screen and see, right? It is clearly visible, everyone. Okay, very good. Now think about it. Was this question difficult? Think about it. Was this question difficult? Right? But if this question would have asked in your normal examination, right, then you would have left it. Yes or no? Right? Seeing the option, you would have left it. Okay? Okay. Now, there's one last type of question which we need to discuss. Okay, so this is about change in, we discussed about change in force, we discussed about the equivalent concept, right? There's one more concept that can be used in this type of problem. What is that concept? Tell me, Harsha, Manoj, everyone, think about it. What can we use, right? Yes, very good, Manoj, right? Thermal properties. Okay, so we can use the change in length due to temperature. Yes or no? So that will change my delta L, na? That will change my delta L, right? So instead of delta L, I can write delta L is equal to what? Tell me. L into alpha delta T. Yes or no? Yes or no? Delta L is L into alpha delta T, right? Right? So this is one more concept that can be asked. Okay, so this will leads to thermal strain, and which again will leads to thermal stress. Okay, got it? So let's see some kind of problem based on that. Okay, so this is what I was talking about. This is what I was talking about. Okay, suppose if I'm having a rod with both end fixed, and it is heated, right? It is heated, then it will expand. Yes or no, right? And the stress is given by Delta L is given by L alpha delta T. So strain is delta L by L, which is alpha delta T. So force is A into Y alpha delta T. Easy? Tell me, easy? Yes? Easy to remember? Now let's try to solve one simple problem based on that. Okay, try to solve this problem. Everyone, try to solve this problem. See, these kind of problems, if you actually know the concept, how easy it is, right? Tell me how easy it is. Yes or no? Try to solve this one. Try to solve this one. Step by step, right? Step by step, everyone should try to solve. Yes, very good. Okay, very good. Okay, Manoj, okay, Prashant. Okay, so see what we have to do over here. I hope all of you understood the concept. I hope all of you understood the concept. Now, when you talk about total change in length, okay, total change in length will be change in length in steel plus change in length in copper. Yes or no? Tell me yes or no. Yes. So delta L is L steel alpha delta T plus L copper alpha delta T. Right, and total change is given 0.002 because this is length, final length, so change is 0.002. Yes or no? Right, got it? Because it is 2 and this changes to 2.002. So from here we can find alpha. Agree? Easy. Now but what we have to find, tell me, this is only first part. Okay, what you have to find? Y and alpha. So alpha is alpha of steel we can find. What is Y? Tell me, what is Y? Young modulus. Yes. So see, right? I can say that steel, either steel or copper, one will contract, one will expand. So X, suppose this is change in length, right? Suppose copper is expanding and steel is contracting. Okay, so change in steel, we can calculate for steel X is equal to what? Tell me, X is equal to, you can just expand this, right? Length of steel into alpha steel into delta T minus what? This strain, है ना? Which is F L by AY. Now, after equating, we can find what? Tell me. F by AY is, sorry, F by AY of steel is alpha steel into delta T, right? Yes or no? Tell me, yes or no? Yes, in same way, for copper we can calculate, right? Yes. Now take the ratio of these two. If you take the ratio of these two, you can find the ratio of Y of steel by Y of copper. Yes or no? This was very good problem, okay. So if you take the ratio, you will get the Y of steel by Y of copper. You can find Y of steel. Got it, everyone? Tell me, got it? Yes or no? Yes or no? Okay, right? Okay, very good, everyone. So the last topic, which I said, okay, wait, this last topic is Poisson's ratio. Okay, Poisson's ratio. Now, basically, Poisson's ratio is the ratio. Okay, Poisson's ratio is just the ratio of latitudinal strain by longitudinal strain. As simple as that. Okay, Poisson ratio is just the ratio of latitudinal strain by longitudinal strain. Okay, that is what we have to know. As simple as that. Okay, got it? Right? That's it. Okay, that's it. So that's it for not today's class. That's it for the solids. I hope